Clay,
Okay, should be filming now, so just zoom in or whatever.
Yeah, it's got the little dot.
Okay, hi Abby, hi Sam. So we have, alright, hush guys, you're on film, your mothers will see this if need be. So we're on the back of the sheet I gave you last week. So, question number 1. Josh.
Yes.
What definition of boiling have we been using up to this point?
100.
I was about to say that.
100 degrees Celsius.
For water, but for in just general.
It's when. Oh, it's the phase change between turning into it. I mean, the liquid turning into a gas.
Perfect. So the phase change where a liquid turns into a gas. The temperature at which a liquid turns into a gas. So write that on as question 1.
Gas.
Where a liquid turns into a gas.
What's the class?
Alright. Write that down. Where a liquid turns into a gas. The temperature at which. Alright. So, Sterling, what definition of boiling are we going to use now? Test question, by the way,
When the
guys.
vapor pressure of a liquid equals atmospheric pressure.
Okay, so our new definition of boiling, where vapor pressure of a liquid equals atmospheric pressure. So a vapor pressure of a liquid is where molecules are evaporating from the surface of the liquid, and the atmospheric pressure, of course, the column of air pressing down. It's boiling now. It's boiling, hopefully 100 degrees Celsius-ish. At normal atmospheric pressure. Now we have to let this boil for a few minutes to drive all the air out of the flask and just have water vapor filling the flask. And to wait for our new and improved stopper, which could cause this experiment to fail completely.
What if they just like
No pressure, Heather.
the top?
I'm sorry, what was your definition for new boiling point?
New boiling point, where vapor pressure of the liquid equals atmospheric pressure.
Vapor pressure.
So we're going to reduce atmospheric pressure in this flask so much that the water will boil at a much different temperature than usual.
It's like on the backside of the sheet.
Yeah, you're filling out the backside.
I know.
Yeah,
Okay.
the definition's right
So,
there.
Yeah.
if
Oh, is it on the front?
number 2 here, Michael, says if atmospheric pressure decreases, then what will happen to the boiling point? Decreases? Yeah. So when atmospheric pressure decreases, boiling temperature decreases. And if atmospheric pressure increases, boiling temperature increases. So they're directly related. So how am I going to create a partial vacuum in this flask? That's question number
You're
3.
gonna use that thing. Suck all the air.
Well, I've driven all the air out
Suck all the
and
air
it's
out.
water vapor, right? So when I plug it and flip it over and cool it off, oh, I'm going to need some cold water too. Gosh.
Dude, you're gonna like make a motion
Yeah.
I'm gonna get like a movie. You know, the person who answers the question, I feel this.
That was fun. There were all the airsoft babies.
So when I plug it and flip it and cool it off really fast, it will cause the water in there to become a liquid again, right? So then there will be very few molecules in the gap where there's no liquid. And that means low pressure, right? Hardly anything pushing down on it. So we'll decrease the pressure by creating a vacuum in the flask by driving out the air, then recondensing the water, then there's nothing in there. So as soon as he comes back with the water, we'll actually do it. Number 4 says at higher altitudes, atmospheric pressure is lower than at lower altitudes. Why? So Sterling kind of already told us this, but Heather, oh, Heather's working. Amy?
How soon do you need what?
Pretty soon.
Well, I think I've gotten them filled.
It's probably good.
Or, like,
Perfect.
that word.
I think it will work.
I
Unless
think
it
I
melts,
need to
then
go
we're just going to have a big
Wash
mess.
my
Big
hands now, please.
Yes, please.
I don't have it on the table.
We'll
I'll
wait
hold
for
it.
you.
You're on-
Thank you
you're on
very
that.
much for
Oh,
your
my
sacrifice for
camera.
science.
It's gross.
It's not gross.
It kind of is.
I don't
It really
scary
is, though.
or anything at all.
Yeah. Hey, do you want me to spit on
Much
it?
grosser things in lab. We had to find the specific gravity of certain bodily fluids
Oh, jeez.
in my anatomy class. So,
Play some.
so nothing, guys. Just keep taking more science classes. You'll see. Wait till you draw your classmates' blood and stuff.
Ooh, that
Yeah,
sounds
no
fun. We can
bodily
make blood.
fluids involved whatsoever in physics.
Yeah, just more.
What are we answering for number 4?
Number 4, at higher altitudes, you can answer, at higher altitudes, atmospheric pressure is lower than at lower altitudes. So
I
why?
already did.
Oh, thank you.
Just spilled that.
It's okay, it's just water.
It's not acid or anything. It's not a weak acid or anything.
It might be here in concrete. So,
I wouldn't be surprised.
Daniel, at higher altitudes, atmospheric pressure is lower. Why? Think of the column of air. If you're up on a mountain, how tall is the column of air that goes all the way up to space?
Smaller, so it's like you're holding more or less.
Right, there's less stuff pushing down on you when you're up on a mountain because space is here. If you're on the mountain, there's this. If you're here at sea level, there's this, right? So atmospheric pressure is lower at lower altitudes. What in the, oh, at higher altitudes, atmospheric pressure is lower than at lower altitudes because that column of air is shorter, less distance. So, Leo, why will it take longer to cook spaghetti in Denver than it does in Ocean City?
New Jersey or Maryland?
I don't
There's a
think.
New Jersey.
What?
Yes, New Jersey is so much better than Maryland.
Listen, focus. So this is Leah.
Excuse
What will
you.
the boiling point of the water that you put that spaghetti in be on a mountain like Denver? Less than 100. So if you cook food at a lower temperature, what will it do? It'll take longer to cook. So in Denver, you need to write down, in Denver it will take longer to cook because the boiling water you're cooking the spaghetti in will not be as hot. And so when you don't heat food as hot, right. All right. So
We're gonna stick the cork in, and we're gonna get like a bubble.
Yeah.
The gum
that'd
is
be
gonna
funny.
start inflating, and it'll be a bubble.
Okay.
No. It's like shaking.
Oh, it just broke the seal.
Yeah, it's okay. So I just need to get this thing out from under it.
Drama.
Yeah, because it could slide down too. That's the thing about faulty ring stands. Oh, I'll just hold it and then we'll be safer. Okay.
Okay, we're safe now.
Much safer.
Sounds good.
Let's see how. Oh, here.
How?
Oh. That's been
This seems safe.
There we go.
Chemistry class, all without safety.
I mean, it's just.
Doesn't work.
It's not
This
like
doesn't
it
seem
will-
unsafe at all. Why do you ask?
This is the scariest thing I do except for sulfuric acid.
Really?
Wish me
You
luck.
have hot water.
Good luck. Do we need to?
It's just water.
Hello.
That was hot. Sorry.
We did it.
Darn it. So.
We did it.
We win.
You
Okay.
did. Yeah.
I have to boil it again, probably.
What? You failed, Heather.
Turn it upside down, then what?
Well, I'll tell you while I boil it again, probably.
Probably.
Yeah. I hate when that happens.
You spilled water all over the floor.
It's not a terrible mess. I mean, at least it's not like
There's no use crying over.
Well, at least it's not warm water. Oh wait.
the sizzling of human flesh, you know.
No, yeah, that was weird. I saw like steam come off your hand. Ow.
Yeah.
No.
It is kind of hot.
Well, at least you got cold water right there.
No, but did you see she stuck her hand on the screw and it like started sizzling and steam.
I don't actually feel it though. I can't get it to.
Don't you have like no nerve endings in the end of one your finger?
I'm pretty good. It's been so many years since I worked in a lab that was dangerous. Actually, you know what? I'm gonna just do it like this.
You know what?
Hello.
And then a noodle stand will at least be available. Anyone see that? There it is. Alright, so we'll boil it again and I'll try one more time and if it doesn't work, then I'll cut my losses. Thank you. I should have
Is
thought
it actually
about
lit? Oh, it is, I guess.
This is hot. Cold. Alright, so it's like flammable material right here.
All of a sudden it burst into flame.
So once it boils, here's the point. So number 3 is kind of like where it's at. See, it's not
Have we
this, I
answered
think.
number 3 yet?
Well, it wasn't necessarily that it was coming out the holes on top. It was more the fact that
It's
the
the
cork
size.
itself isn't.
I have to just get my guts up to hold it still when I do
Do
it.
you want tape?
No, I don't think. Maybe. I
Because you can
wonder.
just be like, then put the thing on top, and then you
I
can
don't
flip
think
it.
the tank will hold it.
Longer.
I don't think it will either, but it's better than what we got.
And then we wrap around, and then we wrap tape around it. Yeah.
Here we go. All right, this should work. I have a metal tool which will not be my hand.
Cool.
If I'm just coordinated enough to do it, that's the problem. So here's what's gonna happen. You saw me try to do it once, so you have some idea of what I'm about to do, hopefully. So I put the stopper in, and then I need to move really fast, so I have to get my courage up. So I'm gonna stopper it, flip it, pour the cold water over it, and what that'll do is all of the water vapor filling this will condense back to liquid, leaving mostly a vacuum. Then there will be practically no atmospheric pressure in that gap, you know, when the thing is upside down, right? Oh darn, there's water in there. In the gap right here, there will be very little atmospheric pressure. So the boiling point will be very, very low because pressure in the flask is very, very low. So that's the answer to number 3. We drive out the water, drive out the air, recondense the water vapor, and we create a partial vacuum in the flask by recondensing the water vapor to liquid. Then there's practically no molecules in that airspace. Okay. So, while that boils again, we'll talk about some other things.
Is that canned
So
air?
gas laws, yeah.
Yes, I love canned air.
Is it like an air horn?
No.
Aw.
So gas laws, think of this. What is the volume of this can gonna do when I let some of this out?
Decrease.
The volume of the can.
You're saying the same.
Stay the same. So this can will not change size. The can will stay the same
But
volume,
we
right?
change temperature though.
Right? It will. So what will happen to the pressure inside when I let some out?
It'll get cold.
Decrease.
Pressure inside will decrease. So what will happen to the temperature?
It'll get colder.
Decrease.
So what equation would I use to think about that?
Pi equals R squared.
No.
E equals MC squared.
So if volume is constant, how does pressure relate to temperature?
Pressure over volume T.
Okay, so we know that, well, actually, I don't want to do that. I want to do this.
Then it'll be like.
T1 V1 over T1 equals
Dude, you cannot read that.
T2. Well, no, not even. I want to do,
Much indecision.
okay. So, I know volume is going to be constant, right? So when pressure goes down, what will happen to temperature? So if pressure goes down, what will happen to temperature? Temperature is going to go down. So if you feel,
Oh, is that like when you use those things,
What's in
the
that can?
condensed air to like clean out your like
Yes,
DVD
that's
player?
what it
It
is.
gets really cold.
so like touch the temperature.
Like when you
and
take a
let it go
CO2
little tiny
Kind of like when you take
Mikey,
like a
Mikey.
spool of air and you let the air out.
Feel the
It's like that.
temperature.
Okay.
Then
Are you?
squirt for
Do you have a
second,
chain of rings on your neck?
And then feel, did it get cold?
Mikey, have you ever had a CO2 canister leak and then you grab it and you like, it freeze burns your hand?
No.
It hurts so
Maybe you
bad.
should let out.
I can feel it.
We should point it the other
Oh, well, that was cold. Yeah, I didn't.
Everyone can have a go at that. This happens.
You know what's hold it.
What am I supposed to
If you point it a certain way, like if you want to shoot like ice out of it,
Oh,
That's CO2.
don't flirt at people.
like what do we like? Oh, wait.
Can we like fashion model with this? Just like the hair
No.
cascade behind us.
Okay, so focus.
What would happen if we sprayed that on like the
So
fire? Would it?
Remember, when pressure decreases, temperature decreases, right? I would maybe put it out, I don't know.
Sweaty.
Yeah, but is it oxygen?
what
Pressure right there is tons of things.
You have to let more out to feel it. So then think this.
Is it shoots
See?
It's more like water.
That's because you just wasted like a bunch of it.
always says it up here.
And it was like ah.
We're not homeschooling.
So think of this now, guys, pay attention.
Yes.
So we
Yes.
have a volume of gas in here, kind of like the boil law experiment, where we were compressing and compressing, and the little column of gas kept shrinking, right? So when I
It
increase
feels like when you go to
pressure
the dentist. Now
right?
start doing stuff with your mouth.
on a gas, amount of gas that can't escape, I compress that gas, what will happen to the temperature inside?
Higher.
I already did this
Temperature
lesson.
inside is going to increase. And you basically can't see it when I do it. Each person will have to do it for yourself, but you'll see like a little puff of smoke. If you, basically what you'll have to do is put it on the table, get your
Fire.
and you can see that it reaches the smoke point. If you hit it
What's
really
in the bottom?
hard,
Let me see. Let me see.
No.
there's like a little scrap of cotton
No.
wool in there,
No.
and it'll get up to its threshold. All right.
No. No. Mr. Dias.
Don't release. No, don't scare the people on the video.
But we already did.
Already did that. Now see, that's what
I was just gonna be like,
Dude, it says great for silk plants.
Serious.
I don't think I'm gonna try it.
All right. So let's think of what I'm gonna do.
Dude, I'm in
gonna
here
plug
teaching
it,
about
hold the
now.
plug, flip it, and dump the water. Right?
I want to see
Actually,
the
hold
ingredients.
on. Josh, you're on the end. Will you dump the water?
Ah, is it hot water?
This is cold water.
Do I have to dump the cold water or the hot
You
water?
dump the cold water
Oh,
onto
okay.
the flask,
Steady
right
hands,
over my
what if,
hands
like,
and everything. Like,
Okay.
Like I died, like,
neglect any
right.
semblance of worrying about a mess.
I wouldn't go all the way to the
So
I
after
would've
you
gone all
dump
the way
it,
to it.
you're gonna put the ice bag right on top of the flask if it is held.
Dude. Dude!
1, 2, 3.
Don't ruin our camera.
That's why
I'm so glad we did this right.
Alright.
Sterling's like,
I feel like Josh should be wearing gloves.
I'm more afraid of goggles.
He won't get burned.
Dude, why are you not wearing
You should be
goggles or
wearing your
googles?
goggles. Where are your goggles?
Make it all smoky.
all smoky.
Dude, did you push it more harder?
There's weed in a bottle.
What?
Okay.
You really are a hippie, aren't you?
Alright. Pour it a little bit now, actually.
Well, we need a
A
bathtub.
little bit, Josh.
Okay, pour.
It's gonna pop. I can see it.
Okay, now ice.
Ice.
Ice, ice.
It's gonna melt it. Watch.
All of a sudden, Heather's chewing gum
It's about to break.
goes out the bottom.
The seal's about to break.
It's not, it's boiling.
No, the seal on the bottom. It's
I don't
dripping water.
No, it's just dripping because we just
Move
dumped
your
it.
He like dumped water.
grubby little hands.
Kind of like
Good
an explosion of water.
As long as you cool it off to create the vacuum, it'll hold the stopper on.
Why is it bubbling?
Like
It's boiling.
there's hairs stuck to the.
Bring a close up here so they can see
He's
it
good.
too.
He's already got it.
Alright.
So, the reason it's still bubbling
Hello,
is because
photo.
it's leaking, although there's a piece of my hair in there which can't be good.
Dude, come on now.
But it's boiling.
That cork is clogged with
Here's
Heather's
what's
chewing
going on,
gum.
just so you make
FYI.
sure, 'cause I
Source
don't
of
want
error.
doing this experiment.
Yeah, source of error, Heather's
What
chewing
is
gum.
in here? Focus and silence. What's in here?
Nothing.
Very little. Mostly a vacuum. In this airspace is mostly a vacuum, right? And then the water is, my hands are shaking. Thank you.
Let's see that.
So that's Fahrenheit. It's 150 in Fahrenheit. Alright, so inside the
Josh.
flask I've got 60 degrees. So this water is still boiling at 60 degrees Celsius. So as long as you decrease the atmospheric pressure, you decrease the boiling point because the water vapor and the,
Wait, it's boiling at 60 degrees.
that's what I'm saying. That's why I do this experiment and risk arm and for you guys. Because nobody will really
Impressive.
believe that atmospheric pressure
Most
equals vapor pressure.
So there's
Until
like
you
no
see it.
atmospheric pressure on it?
There's very little pressure in here, so the boiling point of that water is incredibly low.
So it's still boiling, but it's not actually that hot.
It's 60 degrees.
It's what we've been saying.
65, 66 maybe.
That's Celsius, right?
All of a sudden, the cork is gonna fall
Yeah, not
out.
Fahrenheit.
I mean,
This is gonna
If it was 60 degrees Fahrenheit, we'd all be dead.
60 Fahrenheit?
What?
It's probably about 60
Move on,
Fahrenheit
move on,
here.
move on.
If it were 60 Kelvin,
Isn't absolute zero like minus
0
163?
Kelvin. It's negative 273 Celsius. I don't know about Fahrenheit. I never use Fahrenheit. Speaking of which, do not ever use anything but Kelvin when you're doing gas law problems. If he gives you Celsius, you convert to Kelvin. When you do problems on this test, Kelvin only. Please, for real. 63 degrees and still boiling.
I told
Look at it go.
It's just gonna like sit down.
Okay.
Good job, Mrs.
So, oh, thanks. I am going to shake the rest of it. So, how about this tank? What do you think happens? Constant volume, burning gas, decreasing pressure. Does it feel cold or hot?
Hot.
Hot. Colder.
Man, that is hot right
It's cold. The tank is cold
It all depends on your point of view.
Damn, man, the guy from here.
because the pressure's decreasing, the volume's constant,
Everyone
so temperature
Shoot
decreases.
like a little propane like that.
Of course, the metal's hot.
With a 22 tracer.
All right. Thank you, Josh, for also risking, and Sterling for nearly being hit in the head, and Heather for making it all possible today.
Nearly by like 6. Feels so
To
useful.
work for the team.
All right, and whoever got me paper towels.
You're welcome.
Alrighty. Okay, so now we can move on with our lives. I'm gonna drop everything all day because I'm shaking my knees. Let's do some math, which will calm me down, right? Let's get rid
I
of my
highly
table.
suggest using a different table.
Why is there a math for that?
What? There's a monster outside. What?
Let's call that
I'm not
atmospheric
gonna lie,
pressure.
I started thinking like, so you said there's a monster.
Y'all can stop filming this disaster now. Thank you.
Then I realized that Sterling was his thing. I was like, you picked
What button do I press? Is it this one?
cool.
I think